As part of this sectional module, we are actually going through the details related to filtering on top of Spark data frames. Let's go ahead and make sure that we have a notebook ready so that it can be leveraged to go through several tasks with respect to filtering. This is the same notebook which we have seen earlier. Probably there might be few changes. However, most of the elements with respect to users is the same. You should be able to run these cells to create the data frame. The data frame will be named as users_df. It contains all these columns. You should be able to expand and you should be able to see the details. It contains ID, first name, last name, email, gender, current city, phone numbers which is of type struct, courses which is of type array, is customer, amount paid, customer from, and last updated TS. You should be able to preview the data by saying users_df.show. You can see the output here. So we'll be running this notebook from other notebooks so that this data frame is created. We'll be going through several tasks with respect to filtering using filter or where functions that are available on top of Spark data frames. As part of the sectional module, we are going through the details related to filtering the data that is part of Spark data frames. Let's go ahead and make sure we have a required notebook so that we can create a Spark data frame in subsequent lectures in this sectional module. As we have seen earlier, we will just create data frame using users which is of type list. Each element in this list is of type dict which contain key value pairs for each and every record. Let's go ahead and create the data frame using this list. However, in this case, I would like to define phone numbers as struct, and hence I'm actually using row from the pyspark.sql. Let's import row first. Let's create this list by name users. Now let's run these pieces of code to create the data frame by name users_df. You can see that it is working as expected. You can also review the data once it is completely executed. You can see that it contains 5 records. You can also print the schema. You can get column names using columns, or you can actually get column names as well as data types using dtypes and so forth. With respect to phone numbers, it is of type struct. With respect to courses, it is of type array. All other columns are actually from primitive types. That being said, as we have the required notebook to create the Spark data frame, let's go ahead and use it as part of the subsequent lectures in this section where we'll be covering details about filtering the data that is there as part of the Spark data frame. As part of this lecture, let's get an overview of filter or where function on Spark data frame. This will take care of creating data frame by name users_df. You should be able to review all the columns that are there as part of this data frame. You can also review the data here. That being said, when it comes to filtering the data, we have 2 functions. One is filter, second one is where. Both actually filter the rows based upon certain condition. Whatever rows satisfies the condition will become part of the new data frame. Whatever rows that doesn't satisfy condition will be discarded. You should be able to get the help on filter. You can see that you can pass condition to filter. You can also see few examples here. There are multiple ways where we can actually pass the conditions. This is a Pythonic way of passing the conditions or non-SQL way of passing the conditions. This is a SQL way of passing the conditions. In non-SQL way, we typically use column names as column objects, and then we can actually perform operations like less than, greater than, less than or equal to, greater than or equal to, and then we should be able to compare with the value, and whatever satisfies this condition will be part of new data frame which is written by this piece of code. When it comes to SQL style syntax, we typically pass the condition in single quotes or double quotes like this. Whatever rows that satisfies this condition will be part of the new data frame which is written by this piece of code. Now we also have a function called as where. Where is nothing but alias for function filter. So either you can use where or filter depending upon your preference. As seen here, we can pass conditions either by using SQL style syntax. This is SQL style syntax, or non-SQL style syntax. This is non-SQL style syntax. Also, for non-SQL style, we can pass columns using call function on column name as string, or using the notation of data frame then column name in square brackets like this. Both the approaches return column type object. Using column type object, we should be able to perform conditions using non-SQL style syntax. Now let's go to the examples here. In this case, I'm importing a call. You can see using a call. This is equal condition. So in this case, there's only one record where ID equal to 1. You can actually see the output here. This is using where, because filter and where are nothing but synonyms. When it comes to the condition, it can be same. Whether you want to use filter or where, it doesn't matter. This is where we are actually using column names leveraging the data frame. Even this approach will actually return column type object. So we are performing equal condition on column type object. This is example using filter. This is example using where. Both of them have returned one record where ID equal to 1. Now this is SQL style syntax. You can see we are using filter here. In this case we are using where. When it comes to the condition, it is passed in the form of string. This is SQL style syntax. If you are familiar with SQL, if you use where condition for ID equal to 1, we say where ID equal to 1. That is what is going here. Even you can use double equal to when it comes to equal condition. Either of the approaches will work. This is more common compared to this one when it comes to filtering the data using SQL style when we use equal condition. As filter and where are nothing but synonyms, you should be able to implement similar logic using where as well. If you want to envision this piece of code in the form of SQL, this is how it will be. When it comes to Spark, you can actually create a view using data frame. In this case, data frame name is nothing but users_df. The view name in this session is nothing but users. You can actually write a query like this. Select star from users where ID equal to 1. You should be able to see the data related to ID equal to 1. Whatever goes here can be leveraged here to actually use where or filter where condition is passed using SQL style syntax. So this is how you can actually get started with filter or where functions. When it comes to these functions, we need to understand how different types of conditions can be passed to these based upon the requirements. We'll go through those details as part of subsequent lectures in the sectional module. As part of this sectional module, we are going to the details related to filtering the data in Spark data frames. As seen in the previous lecture, we either use filter or where to filter the data in Spark data frames. As part of filter or where, we need to make sure that we pass conditions or conditional logic to filter the data based upon the condition. If condition is satisfied, then the records will be considered and a new data frame will be created with those considered records. If condition is not satisfied, those records will be discarded while creating the new data frame. That being said, we typically come up with conditions using equal, not equal, greater than, less than, greater than or equal to, less than or equal to, in and between. You should be able to use single equal or double equal to for equal. For not equal, we typically use this approach. For greater than, we use this one. For less than, we use this one. For greater than or equal to, we use this one. For less than or equal to, we use this one. For in operator, if you wanted to use functions, then you use isin on top of column type object. You can also use in operator if you wanted to come up with condition using SQL style syntax. You just have to say column name in, then you have to compare with values. Also, there is something called as contains. Contains is another important function which can be leveraged. So contains is nothing but a function which is similar to in. Let me actually specify as contains function. It is also available on top of column type object. Then comes between. We have function called as between on top of column type object. We can also use between with end if you wanted to come up with a condition using SQL style syntax. Now let's go through a few examples so that you are really comfortable with all these different types of operators which are being used as part of the conditions based upon the requirements. As part of this lecture, let's go to the details related to filtering using equal condition. First, let's create data frame. The data frame name is nothing but users_df. You can see the set of columns that are there as part of this data frame. You can also review the data here. The data frame contains 5 records. That being said, when it comes to filtering the data, either we can use filter function or where function on top of data frame. Both are nothing but synonyms for each other. I'll be using filter for the demo purpose. You can also use where if you prefer where over filter. Now let's go ahead and perform the first task. It is nothing but to get list of customers. When it comes to the definition of customer, customer is nothing but a user where eth_customer flag is set to true. In this case, if you look at this data, there are 3 users, 1, 2 and 3, where eth_customer is set to true, which means these 3 are customers. For 4 and 5, eth_customer is set to false, you can see here, which means they are not customers. They are just users as part of the dataset. As part of this lecture, let's go to the details related to filtering using equal condition on top of Spark data frame. First, let's create a data frame by name users_df. Now users_df is created. You should be able to review the columns by expanding this, and also you should be able to review the data. Now if you scroll down, there are quite a few tasks we can actually perform these tasks to understand how to filter the data on top of Spark data frame. The first task is nothing but to get list of customers. Before getting into the details, first let's import call. Now when it comes to getting list of customers, we need to make sure that is_customer is true. To actually use the syntax in a right way, first we need to understand the data type of is_customer. We can go above and expand this. We should be able to review the data type of is_customer. It is of type Boolean. As is_customer is of type Boolean, we should be able to compare against Boolean values such as true or false using this approach or this approach. Both the approaches will work when we actually use non-SQL style syntax. On the left side, we have column type object. This actually returns a column type object. Using column type object on is_customer, we are actually comparing against true either by passing it as Boolean or by passing it as string. You should be able to run this. It will actually return a list of customers where is_customer flag is set to true. You can see that there are 3 customers. For all these 3, the is_customer flag is true. You can also use this approach and you should be able to get the results. If you want to use where, you can use where as well. Filter and where are nothing but synonyms to each other. You can use either of them to actually filter the data on top of data frame. Now, if you would like to solve this problem using SQL style syntax, then it will look like this. We can actually copy this. Now we should be able to add a new cell. This time we should not be using call function. We can clean up call here. Now when it comes to the condition, either you can specify double equal to like this or single equal to, both will work. First let's run using double equal to, it is working as expected. Now let me remove one and run this. Even this one is working as expected. Now let's specify the condition like this, where T is capital, even it is working. So in this case, when we say true, internally it is of type Boolean only. It is not of type string because it is not enclosed in double quotes or single quotes as part of this condition. You can see that it is working. So we are actually comparing the values in is_customer field with a Boolean value true. Now let's try passing true as string here. Let's see if it works or not. You can see that even it is working. So when it comes to comparing against Boolean values such as true or false, you can pass true or false in the form of string or in the form of Boolean type. In this case, we are passing it as string. That being said, this is the SQL style syntax. If you want to understand SQL query for this, it will be something like this. First, let's create a temporary view. We should be able to say users_df dot create or replace temp view. This is the function which we can leverage. We can actually specify the name for the view. Let's say users. Now we should be able to come up with a SQL query. The SQL query will be like this. We should be able to use spark.sql to actually run SQL query. Also, as we are using Databricks notebooks here, we should be able to use magic %% and then you should be able to say select star from users where is_customer equal to true or true or true. Either of the approaches should work. I think with respect to SQL, we have to use only 1%. Now you should be able to run it. If you are using non-Databricks notebooks and if you want to run this, if %SQL magic is not supported, then you should be able to enclose this as part of spark.sql and it will work without any issues. This is how it will be. Let me clean it up. Now I can say spark.sql, then let me use triple single quotes because I have a condition with double quotes. For that reason, I'm using triple single quotes. Now I can actually line break. Let me format this. Now let me close the triple single quotes. Then I should be able to say show. Now we can actually run and we should be able to see the results. This is how we should be able to use equal condition to get the customers by comparing is_customer with true. In this case, is_customer is of type Boolean. We should be able to pass Boolean values as strings or as Boolean, which are nothing but true or false. Now let's get a list of non-customers. In this case, we are supposed to get those customers where is_customer flag is set to false. If you want to use non-SQL style syntax, you should be able to leverage this. Then you should be able to come up with a solution. Let's add a new cell here. Let's say false. You can see that it is working. You can also use false as string here rather than as boolean. Even this one is working as expected. However, if you just convert this false like this, then it might not work, because false is not a valid Python value. As we are not enclosing in double quotes or single quotes, it will look for false variable. As there is no false variable, it will fail. You can see here. So if you are actually comparing against Python boolean false, you need to make sure that f is capital, then only it will work. Now this will work because false is a valid boolean type constant value. False with lowercase f is not a valid boolean type Python value. That's why it is not working. It was looking for a variable by name false. Yeah, as part of the previous task, we have seen how to compare against boolean type value. Now let's go to the next task where we'll be comparing against string type value. In this case, Dallas is of type string. The problem statement is nothing but get users from Dallas. If you look at the dataset here, we have several columns. One of them is nothing but current city. We can leverage this to get the users from Dallas. So we just have to say current underscore city equal to Dallas to compare against Dallas to get users from Dallas. Now let's add a new cell here. We should be able to say users underscore df dot filter. Then we should be able to say call of current underscore city. We can compare against Dallas by saying double equal to and then Dallas in single quotes or double quotes. Now we can actually say dot show to preview the data. You can see that it is working as expected. You can also use SQL style syntax like this. So in this case, if you want to use SQL style syntax, you need to make sure that the overall condition is in double quotes or single quotes. If you use double quotes for the overall condition, then Dallas should be passed using single quotes. If you use single quotes for the overall condition, then Dallas should be passed using double quotes. Let's go to the details so that you understand. In this case, let me actually replace using double quotes. Now we can say current underscore city double equal to or single equal to Dallas. This is how you should be able to use SQL style syntax to compare column values with a string such as Dallas in this case. Now let's get the customers who paid 900. 900 is of type numeric. When it comes to data types in Spark, the numeric types are nothing but int. Again, with respect to int, there are different variations such as long, big int, etc. Also, we have float, double, etc. So whenever we are actually talking about numeric values, we don't need to pass the values in single quotes or double quotes. We can directly pass. It should work without any issues. Now, with respect to the column which we are supposed to use to actually get those customers who paid $900 or 900 rupees, whatever is the currency, you can see that there is a field called as amount underscore paid. It is of type double. We have to use this field to actually get those customers who have paid 900.o. Now let me scroll down here. Let's come up with the condition using a non-SQL style syntax. It will be like this. You can actually say users underscore df dot filter. Then you can actually specify amount paid like this. First, let's go through the details using a non-SQL style syntax or Pythonic syntax. We have to use column type object on one side of the condition. It can be either side. It need not be on the left side. But the best practice is to use column type objects on left side only. Then we can actually say double equal to, then we should be able to say 900.o. Now we should be able to say show to actually preview the data. You can see that it have returned one record. Let's try to pass the condition using quotes rather than directly. Let's see if it works or not. You can see that it is working. With respect to Boolean as well as numeric types, we can pass the literals either directly or either in single quotes or double quotes like this. Internally, it will actually convert the data type of these values to the data type of the columns on the left side. As numeric values can be converted to strings or as Boolean values can be converted to strings, it will work. And this process is nothing but implicit conversion. So internally, it is taking care of implicitly converting the data type of these values to data type of these columns. So in this case, 900.o, which is of type string, will be converted to double type because amount underscore paid is of type double as part of our actual dataset. Now let's go to the details using SQL style syntax. If you wanted to solve this problem using SQL style syntax, then it will be like this. We can remove call here. we can actually clean this up. As 900 is numeric type, we don't need to pass in quotes. Now you can see that we are getting results using SQL style syntax. However, if you want to pass as strings, you should be able to pass as strings also. Internally, 900 will be converted to numeric type because amount underscore paid is of type numeric. In this case, it is double, and hence this will be converted to double type, and it will be compared against the values. You can see that there is only one record, and we are able to see that record here. Now let's get the customers where paid amount is not a number. First, let's review the data, and then we'll take it further. To review the data, I'm actually saying users underscore df.show. Let's run this. When it comes to the amount underscore paid, you see 3 of the records have actual float or double values. However, for a couple of records, we have NaN. NaN stands for not a number. Now let's go to the details related to how to deal with these values by coming up with solution for this problem statement. The problem statement is nothing but get the customers where paid amount is not a number. In this case, we have to get these 2 records. 4 and 5 have amount paid where they are not numbers. That being said, we can actually import a function called as isName, and then you should be able to run this. Now you can actually review the output. Where amount paid have valid numeric values, it have returned false. Where amount paid have NaNs, it have returned true. So we can leverage isNaN to return true or false based upon whether the column values are numbers or not numbers. If it is not number, then it will return true, otherwise it will return false. Now as this will actually return true or false, we can actually use filter like this, where we can specify isNaN of amount paid. Then we can actually say double equal to true or single equal to true if you want to use SQL style syntax. So this is non-SQL style syntax. You can see that it is working as expected. If you want to use SQL style syntax, you don't need to import isNaN. isNaN is available as part of Spark SQL functions also, and hence you should be able to say isNaN of amount paid equal to true. So this is how it will be. Let me delete. Now let me use single quotes. We can actually say isNaN, then amount paid, then we can actually say single equal to or double equal to, then we should be able to pass Boolean true or string type true. Now we should be able to run, and you can see the results here. This is how you should be able to come up with the solution using SQL style syntax. If you are using SQL style syntax, you don't need to import isNaN because we're actually passing the condition as string completely. If you want to use non-SQL style, then you have to import isNaN, and then you should be able to pass column name like this. Then you can actually compare against Boolean values like this. You can also pass strings in place of Boolean true. However, the string should be true in single quotes or double quotes. This is how we should be able to filter the data in data frame using filter leveraging equal condition. Keep in mind that you need to be aware of data types of the columns while coming up with these conditions. Even though I am demonstrating using equal here, even with respect to other conditions, understanding the data types of the columns is very, very important. If you do not understand the data types of the columns, then you will not be able to pass the values on the other side of the condition using appropriate syntax. As part of this lecture, let's go to the details related to filtering using not equal condition. First, let's create data frame by name users underscore df. Now let's go to the problem statements to understand how to use not equal condition to filter the data on top of Spark data frames. The first problem statement is nothing but get all the users who are not living in Dallas. You should be able to use filter or where to filter the data in a Spark data frame. You can also pass the condition using non-SQL style syntax or SQL style syntax. Now let's come up with the solution for this problem statement using non-SQL style syntax. We'll also see how to get the solution using SQL style syntax. Let me add a cell here. To use non-SQL style syntax, we have to import call. Call is available as part of pyspark.sql.functions, and hence we should be able to say from pyspark.sql.functions import call. Now call is imported. In this case, first let's review only ID and appropriate column to compare against Dallas. The column is nothing but current city. You can see here there is a column called as current city. Let's review the data by only selecting ID and current city, then we'll take it further. Now let's run this and review the output here. If you review the output, 1 is living in Dallas, 2 is living in Houston, 4 is living in San Francisco. There is a null with respect to 5. With 3, you are not seeing anything. If you actually review the users which is used to create the data frame, with respect to user with ID 3, the city is represented using empty string like this. As we have empty string, we are not able to see it here. Keep in mind that it is different from the null value. Now let's go to the details about getting all the users who are not living in Dallas. Let me copy this. Let me add a new cell here. Now let's go with the non-SQL style syntax. For that, you can actually use filter. Then you should be able to say call of current city. Now, as we want to get all those users who are not living in Dallas, we can actually say not equal to like this. Then we should be able to pass Dallas like this. Now, if you try to run this, you will only get 3 records. You can see the 3 records here. They are nothing but users with ID 2, 3 and 4. Even though 5 is not living in Dallas, it is not returning that record because 5 contain null. We will not be able to come up with a solution only by comparing against Dallas here. We also need to make sure that we return those users where current city is null for them. Let me come up with the solution. I haven't covered Boolean operators yet or Boolean conditions yet. You will be understanding the solution at a later point in time. For now, to come up with the solution for the problem statement, I'll be using Boolean OR and then we'll take it further. Now let me add a new cell here. Here to actually use Boolean OR, we should be able to use pipe like this. Then we should be able to specify a call of current city is null. On top of column objects, we have a function called as is null. We should be able to use it to actually compare against null values. In this case, we would like to get even those records where current city is null. However, we need to make sure that the conditions are enclosed in circular brackets like this. Only then it will work. Otherwise, it will try to apply condition on these Dallas and call of current city is null, not against this one, then or this one. To make sure that it works as expected, we need to make sure each and every condition is enclosed as part of circular brackets like this. Only then Boolean OR will work. We'll go to the details again at a later point in time when I cover Boolean OR. For now, let's come up with the solution to get all the users who are not living in city Dallas. Now let's run this. It is saying column object is not callable. Let me see where it is going wrong. First, let me validate whether is null is available on top of current city. For that, I can actually say call of current city, then dot hit tab. Let me search for is null. We have, but n is capital. As I am not using capital N, it is complaining. Let me use capital N here. This time it should work. Now you can see all the 4 records. Even user ID 5 with current city null is returned. This is how you should be able to get the solution for this problem statement. Just using not equal to Dallas is not suffice if you want to see the ID 5 where null is there as part of the current city. Now, if you want to use SQL style syntax for this problem, you can actually copy this, paste here. With respect to this, you need to come up with logic like this. Let me use double quotes here. Now I can say current underscore city equal to Dallas, or we can specify Boolean OR like this when we use SQL style syntax. Current underscore city is null. To deal with null values, we have to use is null or is not null. In this case, we are trying to compare with null, and hence we have to say is null. If you say equal to null, it will not work. Now you should be able to run this and you can see the output. However, the output is incorrect because there is a bug in the code. We are supposed to use not equal to like this. Now we should be able to see the results as per our expectations. When it comes to comparing with null values, this is how we should be comparing. We should not be using equal or not equal. We have to use is null or is not null. If you use non-SQL style syntax, you have to use a function like this. We have is null function and also is not null function. Those are the ones which are supposed to use not equal or not equal operators. That being said, now let's go to the next task. The next task is nothing but get all the users whose city name is not empty string. Nulls can be ignored. In this case, we can ignore the nulls. We want to see only those cities where city names are not empty strings. Now we should be able to come up with the solution fairly quickly. If you want to use non-SQL style syntax, all you need to do is you specify not equal to empty string, then we are good to go. Let me clean up this condition. Now in place of Dallas, we just have to pass empty string like this. Now you can see the output here. We are actually getting all the users where city is not empty string. Nulls are ignored. If you want to get whether the city is not empty or is null, then you have to use is null against current city. Then you should be able to see the details with respect to 5 as well. Now let's come up with the solution using SQL style syntax. For that, I'm just copying this, pasting here. We should be able to delete this. We can actually specify the condition like this. In this case, I'm going to use double quotes. We can say current city not equal to empty string. Now we should be able to run it and we should be able to see the results. This is how we should be able to use not equal to come up with the solution. In this case, we are only comparing against string values. When it comes to comparing against strings, we have to pass the string literals using single quotes or double quotes. However, we might have to compare with non-strings also. They can be numeric, they can be Boolean. You need to make sure that the literals are passed in right manner. Even if you use single quotes or double quotes for numeric as well as Boolean type, it will work. But for some data types, it might not work. Just keep in mind that you need to be aware of data types of the columns before passing the literals so that we can actually get the values which satisfies the condition. As part of this lecture, let's go through the details related to filtering data using between operator. First, let's create the data frame by name users_df. You can actually review the columns along with data types here. In this case, the first task is nothing but to get user ID and email whose last updated timestamp is between 2021 February 15th and 2021 March 15th. We need to make sure that all the records which fall in this category are returned. First, let's review only the ID and last updated timestamp, then we'll actually take it further. We'll also include email as part of the select. To project only ID, email and last updated timestamp, we should be able to say users_df. Then /select, then ID, then email, then last updated timestamp. This is the column which contains the values related to last updated timestamp. Now we should be able to say show. You can see the results here. So in this case, I would like to get all the records from 2021 February 15th and 2021 March 15th. We are supposed to get this one and this one. Now it is a good habit to actually check the data types of the fields, especially that are going to be used as part of conditions, to make sure that the values are passed accordingly. In this case, we need to review the data type of last updated timestamp. It is of type timestamp. As last updated timestamp is of type timestamp, we should be able to pass the values as strings. In this case, we are supposed to get all those records which fall in the date range of 2021 February 18th and 2021 March 15th. Let's go through the solution and then we'll understand how to come up with solutions for these tasks. Let me copy, paste here. Then let me say filter. Now I should be able to say call of last updated TS. As we are using call, first we need to make sure it is imported. So let me say from pyspark.sql.functions import call, then run it to actually import call function. Now we should be able to use between operator to actually pass a range. If you want to use non-SQL style syntax, you have to use function between. Let's get the syntax of between function, then we'll take it further. Between is available on top of column object. So we can actually say C equal to call of last updated TS. Now C is of type column. If you say C dot and hit tab, one of the function is nothing but between. You can see here. Between takes two arguments. One is lower bound, second one is upper bound. We should be able to use this function and we should be able to pass lower bound and upper bound to get those users whose last updated timestamp is between 2021 February 15th and 2021 March 15th. Let's go to the details so that we understand how to come up with the solution using this between function if you want to come up with the solution using non-SQL style syntax. If you want to get help on between, you should be able to say help, then c.between. You can run it. You can actually go through the details here. Now let's use between function on top of column object. We have to pass the lower bound and upper bound. As last updated TS is of type timestamp, we should be able to pass the lower bound and upper bound as strings. In this case, we can actually say 2021 February 15th. Let's only pass date part. Don't pass the timestamp part. We will see whether it is returning the results as per the expectations or not. Now we can actually pass the upper bound. The upper bound is nothing but 2021 March 15th. Now let's run this to see if it actually returns the values as per the expectations. You can see that it is only returning one record. We are supposed to see two records because the user ID 3, the details of that user are last updated on 2021 March 15th, but it is not returning, which means there's a bug in this piece of code. One of the ways to solve the problem is by passing the timestamp as well. We can say 00:00:00. You should be able to review the existing values to understand how it is supposed to be passed. You can see here last updated timestamp only have values up to seconds, and hence we can actually pass up to seconds like this. Now with respect to upper bound, as of now, if you just have 2021 March 15th, it is only comparing up to 2021 March 15th midnight, which is nothing but end of 2021 March 14th. In this case, we are supposed to go till the end of 2021 March 15th. The way we can actually go till the end of 2021 March 15 is like this. We should be able to say 23:59:59. It is nothing but 11 o'clock 59 minutes 59 seconds in the night. Now we should be able to run it and we should be able to see the results. Let's also make sure we understand whether this will be included as part of the results or not. As of now, we have only data up to 15, 16, 55. Let me make sure I copy this. Let me paste here. Let's run this. You can see that it is returning both the values, which means when it comes to using between, whatever is specified as part of the upper bound will also be used. In some databases, it will not be. That's why I'm emphasizing on this. Now we should be able to undo this to 23:59:59. Now you should be able to run and you should be able to see the results. So you need to make sure the conditions are passed appropriately as per the requirement. So we are able to come up with the list of users whose last updated timestamp is between 2021 February 15th and 2021 March 15th, end of the day. Let's go to the solution using SQL style syntax. For that, I am copying this, pasting here. Now, with respect to the condition, we are supposed to use between with end. Only then it will work if we want to use SQL style syntax. So I can say and here. Let me actually enclose the overall condition in double quotes. Now here we should be able to say last updated timestamp between then the condition. As part of the condition, we are supposed to use end so that we can pass lower bound and upper bound. Now you can see the results here. We will also validate using only this value to see if the upper bound includes the value or not. I haven't copied it appropriately. Let me copy. Let me paste. Now let me run this. We can see both the records, which means it is working as per the expectations. Whatever is specified here, even that one will be considered with respect to range when we use between along with end. Now let's undo this. Let's go to the next task. The task is nothing but get all the users whose payment is in the range of 850 and 900. Again, we'll be only displaying ID and relevant column with respect to the payment. If you scroll up, you can see that there is a column called as amount underscore paid. It is of type double. We need to make sure that the condition is passed appropriately, then only it will work. Now let me scroll down. First, let's actually get only ID and amount paid. Then we'll take it further. We can actually say users underscore df, then select ID, then amount paid. Now let me say show. We should be able to see ID and amount paid. We would like to get the values between 850 and 900. So in this case, we should be able to use filter. Let's go to the solution with a non-SQL style syntax. To use non-SQL style syntax, we can say filter, then call, then we can actually pass amount paid to it. Now we should be able to use between. As part of between, we can actually say 850, 900. Now we should be able to run it. You can see the results here. It is working as per the expectations. Now let's come up with the solution using SQL style syntax. Let me copy and paste this. Now we should be able to say filter, then say amount underscore paid between 850 and 900. It is supposed to be 900, not 800. Let me fix it here. Now we should be able to say dot, then backward slash, then show. We should be able to run it. We can see the output here. This is the solution using SQL style syntax. If you try to pass these numeric values as strings, it will actually try to do the implicit conversion and it will try to get us the results, but sometimes the results might not be accurate. Now let's pass 850 and 900 as the strings. To pass 850 and 900 as the strings, we should be able to enclose in double quotes like this. Now we should be able to run it. You can see that it is returning both the values. However, if I actually say users_df select id amount paid, filter of amount paid between 850 and 1000. So in this case, I'm trying to compare against 850 and 1000. Let's see if it works or not. You can see it is working. I thought it will not work, but it is working. The reason why it is working is because when it comes to 850 and 1000, they are implicitly converted to type of amount paid. In this case, amount paid is of type float or double. As this is of type numeric, as these are actually converted to numeric type, it is working as expected. If amount paid is actually converted to string, because we are using string type values here, then it will not work. As it is the other way around, as 850 and 1000 are implicitly converted to float type, it is working as expected. So keep it in mind, sometimes the implicit conversion can cause issues. You need to make sure you evaluate to see if it is working as per your requirements or not. That being said, this is how you should be able to filter the data using between operator. As part of this lecture, let's go to the details related to dealing with null values while filtering data in Spark data frames. First, let's run this. It will take care of creating the data frame for us. The data frame name is nothing but users_df. Now let's perform the task related to getting all the users whose city is not null. This is where we need to understand how to deal with null values. We will not be able to deal with null values using equal and not equal. Instead, we have to use is null and is not null. Let's perform few tasks so that you understand what I'm talking about here. First, let's make sure that we import call function, because if you want to use non-SQL style syntax, we have to create call type object using call function. We should be able to say from pyspark.sql.functions import call, then run it to actually import call function. Now let's actually say users_df, then dot, then backward slash, then select. Let's only select ID, then current city. We are interested in current city to actually filter the data based on city. Now let's say show. We should be able to preview the output here. You can see ID and corresponding city for each and every user. With respect to 5, we have null value. We would like to see all these 4 records where the values are not null. Even for user ID 3, we have empty string. It is not a null value. That being said, if you try to apply filter using equal condition like this, it will not work. So in this case, if I say select ID current city, then filter call of current underscore city, then not equal to, then null. Because null is not a valid Python type, it will actually fail. In this case, you can see the error. It is saying null is not defined because there is nothing like null which is predefined as part of Python as programming language. The closest thing is nothing but none. We can actually say none like this, and you can see that it is not returning anything. You will not be able to pass condition like this with respect to comparing with null values. Instead of using not equal to, we have to use appropriate function which is available on top of column type object to get the results as per the expectations. The function is nothing but is not null. We can leverage is not null, then we should be able to see the results. All the 4 records where current city is not null are returned without any issues. Now, if you would like to apply this condition using SQL style syntax, it will look like this. As part of the filter, we are supposed to say current underscore city is not null. Now, let me actually invoke show so that we can preview the output. You can see all the 4 records without any issues. However, if you try to use not equal condition like this, it will not work. You can see that it is not returning anything. To compare against a null, if you wanted to use SQL style syntax, you have to use is null or is not null. Now you can see the output as per the expectations. Now let's get all the users whose city is null. First, let's come up with the solution using non-SQL style syntax. Let me copy this. Let me paste here. In this case, we just have to say is null. You can see that there is only one record with user ID 5 where current city is null. The empty string is not null. It is empty string only. There is a difference between empty string and null value. Same is the case with numeric and date types. Empty and null are not same. That being said, if you wanted to use SQL style syntax, it will be like this. We should be able to copy this, add a new cell here, paste. We just have to remove not. Then you can run it. You can see the output here. Now let's get all the users where customer from is null. Let's scroll up and review the output here. In this case, we are talking about customer from. Customer from is of type date. Even in this case, we just have to say customer from is null. If you wanted to use SQL style syntax, we have to say customer underscore from dot is null if we wanted to use a non-SQL style syntax. So let's copy this one first. This is related to non-SQL style syntax. Let's paste here. In this case, we are supposed to use customer underscore from. Let me actually copy the column name here, paste, also paste here. Now we should be able to run it. We can see the output here. There are two customers where customer underscore from is null. You can see the details here. The user IDs for those customers are nothing but 4 and 5 respectively. If you want to use SQL style syntax, this is how it will be. We just have to replace current city with customer from. Then we should be good to go. Now let's run it and let's see the results. Make sure you are really comfortable with null values. There is a possibility that you might get 1 or 2 questions as part of the certification exam. Also, in general, dealing with nulls is very, very important with respect to any database related technology. Even as part of the programming language also, dealing with nulls is very, very important. However, we don't use term called as null when it comes to programming languages. We use terms such as none. If it is Python, we use none. Depending upon the programming language which you are using, it might represent in a bit different way. That being said, as part of this lecture, we have gone to the details related to dealing with null values while filtering data in Spark data frames. Make sure you are aware of both is null as well as is not null and try to use those as per your requirements depending upon your situation. When it comes to filtering the data on top of Spark data frames, many times we have to apply multiple conditions. Each and every condition will return true or false. We need to be familiar about Boolean operations to understand how to use multiple conditions to come up with the solutions based upon our problem statements while filtering the data on top of Spark data frame. As part of this lecture, let's get an overview of Boolean operations. You should have seen Boolean operations as part of your high school mathematics. Same goes here. With respect to Boolean operations, we have Boolean OR, Boolean AND, and negation. Negation will reverse the condition. If the condition returns true, negation will give us false. If the condition returns false, the negation will give us true. With respect to Boolean OR, if we have 2 or more conditions, if one of the condition is true, then Boolean OR of all the conditions will always return true. When it comes to Boolean AND, if we have 2 or more conditions, if one of the condition return false, then Boolean AND will actually return false. Let's go through the examples with 2 conditions. In this case, let's assume we have one condition which is returning true, another condition which is returning true. As we are using Boolean OR, it will return true only. Same is the case with true or false or true. As long as one of the conditions is true, Boolean OR always return true. When it comes to both the conditions returning false, Boolean OR will return false. Now, with respect to Boolean AND, all the conditions should return true so that Boolean AND can return true. In this case, this will return true. However, the rest of the 3 conditions, false and true, true and false, as well as false and false, will return false. Now comes not true and not false. You will see false with respect to not true. You will see true with respect to not false. This is how you should be able to quickly review Boolean operations. Keep in mind that if one of the conditions is true, Boolean OR always return true. If one of the condition is false, Boolean AND will always return false. As we got an overview of Boolean operations, now let's go to the details about using Boolean operations while filtering the data as part of the Spark data frames. We'll be covering those details as part of subsequent lectures in this sectional module. As part of this lecture, let's go to the details about using Boolean OR on same column of Spark data frame and also in operator. In operator and Boolean OR on same column are related. That's why we're going to cover both in this lecture. First, let's create data frame by name users_df. Now let's import call function. Let's define the problem statement so that we understand the details related to Boolean OR. Then we'll also see how to replace that with in operator rather than using Boolean OR. And also we'll actually go to the details about when a Boolean OR can be changed to in operator and when we cannot change it. Now the problem statement is nothing but get list of users whose city is null or empty string. Already we have seen the solution earlier. Now we will be reiterating and you should be able to understand how to come up with this solution. But before going to those details, first let's review the data. For that I'm actually saying users_df, then select, then ID, then current city. Now let me say show. We should be able to see the details here. You can see that there are 5 users. For 5 users, we have only 3 cities. 3 of the users are living in cities such as Dallas, Houston, and San Francisco. For one user, we have empty string. For another user, we have null value. Null and empty string are different. Now, in this case, the problem statement is nothing but we have to get the list of users whose city is null or empty string. With respect to the solution, it will be like this. If you are going to use non-SQL style syntax, you should be able to specify the filter in this manner. However, the select is not properly completed. Let me make sure this is completed. In this case, let me only select ID and then current city. There is one unnecessary single quote. I have to clean it up. Now, as part of the filter, we have 2 conditions. This is one condition. You keenly observe here. This condition is enclosed in circular brackets. Then we have another condition. Even this condition is enclosed in circular brackets. When it comes to this condition, we are actually comparing against empty string. When it comes to this condition, we are actually comparing against null by using isNull function that is available on top of column object. Between these 2 conditions which are enclosed as part of the circular brackets, we have Boolean OR operator. This is how we should be able to specify Boolean OR if you are using a non-SQL style syntax while filtering the data on top of data frame. Now, if you run it, it will return the results as per the expectations. We should be seeing 2 records. User with ID 3 have empty string with respect to current city. User with ID 5 have null value. Now, if you do not have circular brackets on the conditions, then it will throw error. So let me paste here. This will fail because conditions are not enclosed in circular brackets. When we use operator like this to perform Boolean OR, this should be of type Boolean. It should be either true or false. Even this expression should be true or false, which is nothing but of type Boolean. However, if you try to remove these circular brackets, in this case, we are trying to perform the Boolean OR on string, then column type. It is not between Boolean and Boolean type. That is why it will fail. You can see that it is failing. Now, if I use this piece of code and if I actually enclose this as part of the circular brackets, then after Boolean OR, if we remove these circular brackets, then run this, it will work. You can see that it is working as expected. The reason is, in this case, this will be of type Boolean. Even this one will be of type Boolean. And we are performing OR on top of 2 Boolean type values, and hence it is working as per the expectations. Earlier, when we actually remove the circular brackets on the left side condition to the OR, it was actually performing the Boolean OR on string type and then column type. And that's why it was not working. That's why you are seeing issues such as method or blah 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 does not exist. It is referring to string. In this case, the string is coming from here. You need to keep in mind that all those conditions which uses operators such as equal, not equal, greater than, less than, etc. are enclosed as part of the circular brackets. Then only Boolean OR will work. Same is the case with Boolean AND. We'll also look into these details when it comes to Boolean AND as part of the next lecture. Now, we should be able to perform Boolean OR using SQL style syntax like this. We just have to use OR operator like this. In this case, you don't need to enclose these as part of the circular brackets. It will work without any issues. You should be able to run and we should be able to see the results. Let me only select these 2 fields rather than selecting everything so that we can actually review the output. Let me reformat this. Now let me run this. We should be able to see the output without any issues. So this is how we should be able to implement Boolean OR using SQL style syntax. Keep in mind that we don't need to enclose the individual conditions in circular brackets when we use Boolean OR leveraging SQL style syntax. Now let's perform another task. This time we will be getting list of users whose city is either Houston or Dallas. You can actually first review the data, then we'll actually take it further. Let me actually say users_df.select. We'll be interested only in ID and current city. Let's say show. you can actually see the details here. In this case, we are supposed to get details with respect to users 1 and 2 who are living in Dallas or Houston. Now you should be able to specify the condition using Boolean OR like this. You can see that we have condition call of current city double equal to Houston, then call of current city double equal to Dallas. However, it is not recommended to use this approach, especially when we are actually applying condition on the same column with equal by comparing against multiple values. Instead of using a Boolean OR like this, we should be able to leverage in. We'll actually go to the solution using in very soon. However, we can also solve these problems using Boolean OR, but it is not recommended. We typically use Boolean OR when we want to perform Boolean OR on multiple columns, or when we have conditions which are not equal in nature. Now we should be able to use this piece of code to use Boolean OR for this problem statement using SQL style syntax. This is how we should be able to leverage SQL style syntax, and we should be able to compare current city against Houston as well as Dallas using equal. However, if you would like to use in rather than Boolean OR like this, this is how it will be, especially if you are using non-SQL style syntax. On top of column type object, we have a function called as isin. As part of the isin, we should be able to pass the list of values against which we want to compare current city. In this case, as long as the current city is equal to Houston or Dallas, it will actually return the results. Using this approach is better readable compared to using this approach. However, if you want to continue using this approach, you can do so as long as you have only 2 or 3 values that are supposed to be compared with. If you have a bunch of values, then it is not a good practice to repeat the same column again and again. The readability of the query is compromised, and also the performance might be a bit poor when you try to specify too many conditions with same column name with different values. That being said, now you can also use SQL style syntax leveraging in operator for this task. This is how it will look like. You just have to say current city, then in. After that, you have to use the circular brackets like this. As part of the circular brackets, you can pass as many values as you want. Now you can see the users who are living in Dallas or Houston. Now let's perform another task. It is nothing but get list of users whose city is either Houston or Dallas or empty string. For this also, we should be able to use in operator. In this case, I have just said is in Houston, Dallas and empty string. It should work without any issues. If you want to use SQL style syntax, this is how it will work. You can actually remove null. Null is not important here. You can just pass the empty string and run it. You can see that it is working as expected. Even if you add null, it will be ineffective. You can see here, it is still returning only 3 rows. However, we should not be adding null like this. In case if we have to compare with null, we have to make sure that we use Boolean OR and have a separate condition to compare against null value. That being said, let's perform another task to understand how to deal with null values in this type of scenarios. In this case, we would like to get list of users whose city is either Houston or Dallas or empty string or null. In this case, if you pass null as part of in like this, or even using isin function on top of column type object, it will not work. It will just ignore the record with null value, because this is not how you can actually compare with nulls. You have to use is null operator to actually compare against null. This is how you should be able to come up with the solution. You have to use Boolean OR like this, and then you should be able to see the record where the current city is null. If you wanted to use SQL style syntax, it will be like this. So we should be able to copy this, paste here. We have to remove null from here. Then we have to say or current underscore city is null. Now we should be able to run it. We can see the output here. This is how you should be able to use Boolean OR on same column. In case if we have to perform equal condition on multiple values against same column, then we should be able to replace Boolean OR with in operator like this. It should work without any issues. However, if you have to deal with null values, you have to fall back onto Boolean OR and you have to perform comparison with null like this. Make sure you keep all these things in mind with respect to Boolean OR on same column, and also understanding the relevance of in operator when it compared to Boolean OR on same column. As part of this lecture, let's go to the details related to filtering with greater than and less than on Spark data frames. First, let's create the data frame by name users_df. With respect to greater than and less than, we have 4 different types of conditions. They are nothing but greater than, less than, greater than or equal to, less than or equal to. When it comes to greater than or equal to, it is equivalent to Boolean OR with col1 greater than val1 or cal1 equal to val1. When it comes to less than or equal to, it is equivalent to Boolean with col1 less than val1 or cal1 equal to val1. However, it is better to use this notation rather than using Boolean OR like this when we try to compare a particular column with greater than or equal to with the same value. That being said, let's perform few tasks so that we understand the details with respect to filtering with greater than as well as less than on Spark data frames. First, let's try to get customers who paid greater than 900. First, let's review the data. For that, I'm actually saying users_df. Then I'm actually selecting only the ID, then amount paid. Now we should be able to say show to preview the results. We can see the values related to these two columns. Now we would like to get all those user details where amount paid is greater than 900. The way we should be able to come up with a solution is like this. So let me copy, paste. In this case, I'll be applying filter before select. I'm using select to make sure that I only see ID and amount paid, discarding rest of the columns. Now we should be able to say call of amount underscore paid, then greater than 900. This is using a non-SQL style syntax. Now we should be able to line break here. Before running this, we need to make sure that call is imported. Let me import call here. Let me add a cell here. Now let me say from pyspark.sql.functions import call. Now call is imported. Now we should be able to run this without any issues. You can see that you are able to get those records where amount paid is greater than 900. However, it is also displaying the ones where the values are not numbers. I don't know why it is actually returning these two records. It is not supposed to show these two. That being said, to filter out, we need to improvise it. The way we should be able to improvise it is like this. We should be able to say end, and then we have to specify the additional condition. Even this condition is supposed to be as part of the circular brackets. Otherwise, it will throw error. We have seen that with respect to R as well in the past. When it comes to using AND with respect to non-SQL style syntax, we have to use ampersand, not AND keyword. Now we should be able to say call of amount paid, then is nan. The function is nothing but this one. We need to make sure that it is false. So in this case, we can say equal to false. Now we should be able to run it. However, it is complaining saying column object is not callable. Let's see what is going wrong here. The function could be incorrect here. Let's make sure that we actually specify the call of amount paid to create column type object. Then you should be able to say dot and hit tab. Now we should be able to search for is. There is no nan function here. So the function is not right. The function is part of pyspark.sql.functions. Here we need to import is nan. Now we have to say is nan on top of call of amount paid. Now we have to clean this up. Let me remove this. Now it should work. I think I haven't run this. I need to first run this. Now we run this. We should be able to run even this cell. Now you can see the output here. This is how you should be able to get those customers who paid greater than 900. You can see there's only one user with the ID 1 who have paid $1,000.55. It is obviously greater than 900 and hence it is showing the results. That being said, now if you want to use SQL style syntax, it will look like this. So in this case, I can say users_df dot then filter. As part of the filter, we have to specify the condition like this. Amount paid greater than 900. Now let's run this to see what all it will actually show. You can see it is returning all the three rows. So we need to make sure that we add end condition. In SQL style syntax, we have to add end condition like this. When it comes to keywords such as and, or, etc., they can be case insensitive, which means you can actually type in any case. It can be lowercase or uppercase. I typically follow uppercase with respect to any of the keywords. That's why I'm typing and in uppercase. Same is the case with or as part of the previous lecture. Now we should be able to say is nan amount underscore paid equal to false. Now we should be able to run this and we can actually see only one record. Now let's solve this problem where we want to get customers who paid less than 900. The logic is pretty straightforward. You just have to copy this, paste here. In this case, instead of saying greater than, we just have to say less than. Now we should be able to see the results. If you wanted to use SQL style syntax, you can leverage this. We just have to change the direction of the symbol here. It has to be less than here. Now we should be able to run it and we should be able to see the record where the user with ID 3 who actually paid 850.55 is returned. Now let's perform another task. This time we'll actually get customers who paid greater than or equals to 900. Once again, we should be able to copy this. Now we should be able to paste it here. In this case, we just have to change this. Now we should be able to see the results. It have actually returned two records, one with $1,000.55, the other one with $900. Now, if you want to use SQL style syntax, you can actually copy this part, paste, then change this to greater than or equal to. It should work the way it is supposed to be. You can see the two records here. You can also use OR operator, but it is not a good practice. Whenever you have to compare a particular column with the same value using greater than as well as equal, you have to use greater than or equal to like this. We should not be using OR operator. It is not a good practice at all. That being said, now let's perform another task, which is nothing but get customers who paid less than or equals to 900. Let me actually copy the solution from here. This is non-SQL style syntax. Now we should be able to add a new cell here, paste it. Here we have to say less than or equal to. Now it should work without any issues. We can see that there are two records where amount paid is less than or equal to 900. Now let's try to get the solution using SQL style syntax. We should be able to pick this. This is related to greater than or equal to. We need to make sure that we improvise it to make sure we have less than or equal to. We can actually say less than or equal to here. Now we should be able to run it. We should be able to see the results. This is how you should be able to use greater than, less than, greater than or equal to, or less than or equal to based upon the problem statement and get the desired results. Now let's perform another task. This time we would like to get the users who became customers after 2021 January 21st. So in this case, we are supposed to use greater than or equal to 2021 January 21st. Let's go through the solution so that you understand how to come up with solutions for problem statements like this. In this case, we are supposed to compare a particular column which contain date values. Then we should be able to get the results as per the expectations. First, let's preview the data. For that, I'm actually saying users underscore df, then select. As part of select, I'll be passing ID as well as customer from. These two are the fields which I'm interested in with respect to this problem statement, and hence I'm saying customer from here. Now let me actually say show. We should be able to preview the data. In this case, we would like to get all the records which are having customer from greater than 2021 January 21st. It is saying who became customers after 2021 January 21st. As we are saying who became customers after 2021 January 21st, we need to use greater than 2021 January 21st. Now let's come up with the solution for this problem. I'm copying this. Let's use non-SQL style syntax. For that, we should be able to say filter. Then we can actually say call off. Now we should be able to pass the column name, which is nothing but customer underscore from. In this case, we are supposed to compare with 2021 January 21st. Now let's say dot and then backward slash. Then let's run this. You can actually see the results. There is only one customer who became customer after 2021 January 21st. The ID for that customer is nothing but 2. In this case, you can see that it haven't returned the null values. We don't need to deal with null values. If it actually contain NINs, however, customer underscore from will not contain NIN because customer underscore from is of type date. Dates will not have NINs. Either you will have valid dates or you will have nulls like this. With respect to nulls, you don't need to deal with them, as the conditions will not be applied on top of those rows where customer from is having null value. That being said, now let's try to explore this using SQL style syntax. When it comes to SQL style syntax, it will be like this. Customer from, then greater than, As the main condition is enclosed in a single quotes, we need to make sure that this date is passed in double quotes like this. Now we should be able to see the results without any issues. This is how we should be able to filter with greater than or less than or greater than or equal to or less than or equal to on top of Spark data frames. As part of this lecture, let's go to the details related to Boolean end condition on Spark data frames. Already we have seen a couple of examples in previous lecture. We'll be going through few additional examples to understand the relevance of Boolean end condition while filtering the data on Spark data frames. First, let's run this cell. It will take care of creating a data frame by name users_df. You can see that it is created. You can also review the data here. If you review the columns, you can see that we have ID, first name, last name, email, gender, etc. Now, when it comes to the first task or problem statement with respect to this lecture, it is nothing but get mail customers. Before going to the solution, let's make sure we understand what mail customer mean. When it comes to the mail customer, it means gender should be male and also is customer should be set to true. Now let's go ahead and come up with the solution using Boolean end for this problem statement. First, let's review the data. The data frame name is nothing but users_df. We should be able to select whatever fields we want. In this case, I'm going to select ID, then gender, and also is_customer. Now let's say show and then see the results. You can see the 5 records. In this case, we are supposed to get 1 and 2 because both of them have male with respect to gender and true with respect to is customer. Let's come up with the solution. I'll be applying filter on top of users_df. First, I'll be coming up with a solution using non-SQL style syntax. To use non-SQL style syntax, first we need to import call. Let's import call. For that, we should be able to say from pyspark.sql.functions import call. Now here I should be able to add filter. As part of the filter, I can actually say call of gender. Then I have to compare with male. We have to use double equal to like this. Then we should be able to say male. It will actually give us all the male users. It includes both customers as well as non-customers. You can see that there are 3 users whose gender is male. Now we need to improvise on this to actually get only the customers who are male. For that, we have to use and. The way we can specify and is like this. We have to use ampersand. Now we have to say call of is_customer. Then we have to compare with true or false. In this case, we are supposed to compare with true. We can actually say double equal to true. Either you can pass Boolean value like this, or you can also pass true as a string. However, if you want to pass it as string, you have to enclose it in single quotes or double quotes. When it comes to column names to call, we have to pass it using single quotes or double quotes. Now, if we run it, it will fail because it will actually try to apply Boolean end between male then column type object, which is not correct, and hence it will fail. You can see that it is failing. To fix this, we need to make sure each of these conditions which are returning Boolean type values are enclosed in circular brackets. Once we enclose these in circular brackets, it should work. Now you can see that we are getting only male customers. If you want to use SQL style syntax, then it will be like this. As part of the filter, we can remove this. After removing this, we can actually use double quotes or single quotes. Let me use the double quotes here. In that, we should be able to say gender equal to male. When it comes to equal condition using SQL style syntax, either you can use single equal to or double equal to. Both will work. Now we can say and. Then we have to say is customer equal to true. Now you can see that it returns the results as per the expectations. This time we have used SQL style syntax. Keep in mind that when we use SQL style syntax, we don't need to enclose these conditions using circle brackets. However, with respect to non-SQL style syntax, each and every condition which return true or false is supposed to be enclosed using circular brackets like this. Otherwise, it might not work. That being said, now let's go to the another task. It is nothing but get the users who become customers between 2021 January 20th and 2021 February 15th. This can be solved either by using between with and, or we should be able to use Boolean and condition as well. In this case, we'll be using Boolean and condition to come up with the solution for this problem. First, let's preview the data. Let me copy this piece of code. Let me paste here. In this case, I'm interested only in ID and customer from. Let me delete one of the columns here. Now let me add customer_from as one of the columns as part of select so that we can preview the data related to ID and customer from. Now we would like to get the customers who became customers between 2021 January 20th and 2021 February 15th, which means we should be able to see these two records. Let's go through the details about how to come up with the solution to get these two records using Boolean AND condition. Let's copy this. Let's paste here. As part of filter, here we have to use customer from. Let me say customer from. Now I can say greater than or equal to, then the date. In this case, it is nothing but 2021 January 20th. So let me say 01/20. Now let me copy this. Let me replace this with that. Now I have to use less than or equal to. The upper bound is nothing but 2021 February 15th. So we can actually say 0 to 15. These are also known as lower bound and upper bound. With respect to the condition, the lower bound is nothing but 2021 January 20th. You can see here. The upper bound is nothing but 2021 February 15th. You can see here. Now we are ready with the required logic. Let's run this. You can see the output here. However, I'm actually selecting ID, gender, and is customer. I would like to see customer from. So let me copy and paste customer from here. Now let me clean this up. Now we should be able to see the details with respect to the users who are customers starting from 2021 January 21st. Now, if you would like to use SQL style syntax, it will be like this. You should be able to copy, paste here. Now you should be able to delete this. Let me have the main condition using double quotes. In this, we should be able to say customer underscore from, then greater than or equal to 2021 January 20th. Let me copy and paste here. Then we should be able to say and, then customer underscore from. This time it has to be less than or equal to 2021 February 15th. Let me copy, paste here. Now we should be able to run it and we can actually see the results. We have achieved the same results using SQL style syntax. When it comes to using SQL style syntax, we don't need to enclose these conditions as part of the circular brackets. Even without enclosing, it will work without any issues. However, when we use non-SQL style syntax, we need to make sure that the conditions are enclosed circular brackets, especially when we have operators like this. If you have functions on top of column type objects, then it is optional to specify the condition as part of the circular brackets. But if we have operators such as equal, not equal, greater than or equal to, less than or equal to, etc., you need to make sure that the whole condition is enclosed in circular brackets. This is how you should be able to implement Boolean AND condition on top of Spark data frames while filtering the data. It is very, very important for you to be comfortable with it. So make sure you practice enough and be comfortable with using Boolean AND condition on top of Spark data frames to filter the data based upon the requirements. As part of this lecture, let's go to the details related to Boolean OR on different columns of a Spark data frame. First, let's create a data frame. This will actually take care of creating a data frame by name users_df. When it comes to implementing the logic using non-SQL syntax, we need to make sure we use call to create column object, and hence once the data frame is created, let's make sure that call is imported. This will take care of importing the call. Now call is imported. When it comes to the problem statement, it says get ID and email of users who are not customers or city contain empty string, which means we need to use the logic where is_customer equal to false or city is empty. This is what we meant when we say Boolean OR on different columns of a Spark data frame. In this case, we have to apply Boolean OR on top of two conditions on two different columns. One is_customer, second one is current city. Let's actually preview the data, then we'll actually take care of coming up with a solution, first by using non-SQL style syntax, then by using SQL style syntax. In this case, you should be able to review ID, email, current city, as well as is customer. Now, once we come up with the solution, it has to return these two records. These are not customers, and also this one where current city is empty. Let's come up with the solution. First, let's copy this. Let's paste it here. Now we need to add filter. Let's say filter. Let's make sure that there is a line break. In this case, we are supposed to use Boolean OR. This is how we should be able to specify Boolean OR. As part of the first condition, I'll be using current city. So let me say call current_city. In this case, we are interested in those users where current city is empty. We should be able to say double equal to like this and then pass empty string. Now we have the logic to get all those users where current city is empty. We should be able to validate by deleting this. Let me delete this. Now let me run it. We should be able to see the users where current city is empty. Now we need to add OR, and then we have to add additional condition for those users who are not customers. For that, we should be able to say call of is underscore customer. Then we should be able to compare against true or false. In this case, we are supposed to compare against false. False can be passed as a Boolean value like this, or we should be able to pass as a string. However, if you want to pass false as a string, then you have to enclose it in single quotes or double quotes. Let's review the problem statement once again. Then we'll actually run it to see whether we'll be getting the results as per the problem statement or not. When it comes to problem statement, it is nothing but get ID and email of users who are not customers. This is what the condition which actually take care of checking for whether the users are customers or not. Or city contain empty string. We have the logic to compare against the empty string here, which means we should be good to go. Now we should be able to run this and we should be able to see the results as per the expectations. We got the 3 records. 2 of them are related to those who are not customers. 1 of them is related to current city being empty. This is how you should be able to come up with Boolean OR on different columns using non-SQL style syntax to filter the data from Spark data frame. Now let's go to the details related to SQL style syntax. For that, let me copy this. Let me paste here. Now I just have to say filter. As part of the filter, I need to make sure that I have Boolean OR. The way you can specify Boolean OR is by using a keyword called as OR like this. Around OR, we need to have appropriate conditions. Now let's come up with the first condition. The first condition is nothing but current underscore city equal to empty or empty string. Then the second condition is nothing but is underscore customer equal to false. Now if you run it, you should be able to see the results. It also have returned 3 records. This is how you should be able to apply filter on top of multiple columns using Boolean OR. Now let's perform another task so that we are really comfortable with Boolean OR on different columns. The other task is nothing but get ID and email of users who are not customers or customers whose last updated time is before 2021 March 1st. Here also we are supposed to use Boolean OR. Let's come up with the solution for this problem statement using Boolean OR. In this case, we would like to review details related to ID, email, is customer and last updated TS. Then we'll actually come up with the solution using Boolean OR, both by using non-SQL style syntax as well as SQL style syntax. Let me run this. You can see the output here. Now let me say users underscore df dot filter. For that I should be able to use the same piece of code. I have pasted it. Now we should be able to say filter. In this case, we are supposed to use Boolean OR. The way we typically specify Boolean OR is like this. Circular brackets for one condition, then Boolean OR, then another circular brackets for another condition. Now first let's actually add the condition related to not customers. So in this case we have to say is underscore customer equal to false. So we can actually specify is underscore customer as column object like this. Then we should be able to specify equal to, then false. Now the condition related to not customers is taken care of. The other condition is supposed to be customers whose last updated time is before 2021 March 1st. In this case, we have 2 records whose last updated timestamp is before 2021 March 1st. We need to get these 2 records. It is before, not before or equal, which means it should consider only those records up to 2021 February 28th. Now let's come up with the solution here. Here we need to make sure that we use less than 2021 March 1st. The way we can take care of it is like this. We can say call of last underscore updated underscore TS, then less than 2021 March 1st. Now we should be able to run it and we should be able to see the results. You can see that there are 4 records. 2 of them are related to not customers. 2 of them are related to those users whose last updated timestamp is less than 2021 March 1st. Let's come up with the solution using SQL style syntax as well. For that, we should be able to copy this, paste here. We can clean up this. As part of double quotes, we should be able to come up with Boolean OR. The first condition can be is customer equal to false. The second condition can be last underscore updated underscore TS less than 2021 March 1st. Make sure there are no typos with respect to the date. If you have typos with respect to date, then it will not work as expected. This is how you should be able to pass the date, because last updated timestamp have timestamp using a similar format. Now let's run this. We should be able to see the results without any issues. This is how we can actually come up with Boolean OR on different columns of a Spark data frame while filtering the data on top of Spark data frames using functions such as filter or where.